Okay, this topic, ordering numbers with positive exponents. On these, we're supposed to be using our exponent rules. So if you go back to your exponent rules, we know that if we have bases of the same, like a times an a, and those powers, let's say like we call them n and m, then if we're multiplying bases of the same, the a's are the bases, the n and the m are the exponents, then we get the base and we're supposed to add the powers. So we can use this rule. Okay, we can use this rule going this way or this way, meaning if we have two bases, we can add the powers, or if we had one base, we can break the powers up. Okay, and so that's what you're supposed to be using on these problems. So if you notice on the first one, we don't have the same bases, but on this one we have the same powers. Okay, so this is telling me that I can take 3 times 5 and raise it to the third power because the power was the same. So then this becomes 15 to the third. And I'm trying to compare 15 to the third with 15 to the fifth. And obviously 15 to the fifth is going to be larger. Okay. So for the second one, I have 3 to the fifth times 3 to the third. And I'm supposed to compare that with 3 to the 15th. So if you notice on this one, you have bases of the same. So on this one, my base would stay 3, and then I'm supposed to add the two powers together. So this would be 3 to the 8th, and I'm comparing it to 3 to the 15th. And obviously, 3 times itself, 3 times 3 times 3 times 3, 15 times, is going to be larger than 3 times itself, 8 times, 3 times 3 times 3, 8 times. So my answer would be is less than. Okay, now the last one's a little trickier. It's not any harder, but it is a little, you have to think about it. My camera's acting crazy. Hang on. Okay, so for the last one, I have 3 to the 5th times 5 to the 3rd, and I want to compare that to 15 to the 3rd. Well, I can't do anything on this side because my bases are different and my powers are different. So I'm just going to have to leave this as is. But when I come over here, I know that 15 has factors of 3 and 5. So if I wanted to, I could write this as 3 times 5 because 15 is 3 times 5 raised to the third power. So that's one of my next exponent rules. And my exponent rule says that if I have a base multiplied by another base, and that's raised to a power, then those factors on the inside would each get that power. Okay, that's called power of a product. Power of a product. And so what I can do now is say, oh, okay, these are multiplied together, and so the 3 is going to get the third power, and the 5 is going to get the third power. So I'm comparing this to 3 to the 5th times 5 to the 3rd. So you notice that I have a 5 to the 3rd on both sides, so those sort of kind of cancel each other out. So what technically I'm comparing is a 3 to the 5th and a 3 to the 3rd, and obviously a 3 to the 5th is going to be greater. So my symbol here would be the greater than symbol. Okay, so you're using your rules. If you have the same powers, you multiply the bases together. If you have the same bases, you add the powers together. And if you don't have anything the same, then you need to break your base up on the other side into factors.